Hello everyone, welcome back to my channel. In this tutorial, you will learn about the multithreading in Java. And this is one of the most important topics in core Java, so I'll be explaining that in an easier way. Okay, let us understand what is thread in Java. What is thread? Thread is a part of the program which has a separate path of execution. A thread is a part of the program that has a separate path of execution. Now, what is multithreading? What is multithreading? Multithreading. What is multithreading? The process of running the multiple threads. The process of running the multiple threads concurrently. This is very important. The process of running multiple threads concurrently. This process is called multithreading. Now let us understand the advantages of multithreading. Multithreading helps us to increase the performance of the application that we develop. Why? Because it will not consume a separate memory space. It will just use the program space for executing, and it will not consider any extra time. It will be considering the idle time of the CPU. That is why multithreading is introduced. To utilize the CPU's idle time, the multithreading is introduced. So that is why this will be very quick and very efficient as well. Next, why is multithreading a lightweight? Multithreading is actually lightweight because whenever a thread is created within a program, it will not occupy any separate space, like I said before. So it will share the same memory space of that of the program. Okay, and it will not consume more resources, and this is another advantage. It will not consume more resources, and hence we can say it is a lightweight. It will consume program's memory space rather than consuming the space of its own. And one more thing, it will not consume extra resources, hence it is lightweight. Okay, so this much is enough as of now. What is thread? Thread is a part of the program that has a separate path of execution. What is multithreading? The process of running multiple threads concurrently is called multithreading. What are the advantages? Multithreading helps us to increase the performance of our application. Why? It is because it will consume program's memory space rather than consuming the space of its own. And also it is lightweight because it will not consume extra resources. So after understanding this much, let's dive into the. Now I have already created one project with the name multithreading in Eclipse. So I have already created a package in src folder. Now let me create one main class. Let me call that as threads demonstration class. Because this is a main class, I'll be taking this public static void main, and I'll click on finish. Yes, my main class is now ready. Within this method, I will start writing my code. Let me write this program illustrates about the multi-threading. Right. Now, you need to understand that a thread is already running in the background. I have not created any sort of thread as of now, but a thread is already running in the background. Which thread is that? That thread is nothing but the main thread. So to understand that, let me call thread dot, there is one method with the name current thread. Here you go, in thread class, current thread dot get name. If you print what is there inside this, you will get to know what thread is already running in the background. I'll run the program and you can see this program illustrates about the multi-threading. This is this line, and I have printed thread.current_thread.getName. I'm trying to print the current thread's name. This is a method which is already present in the class. This method, the current thread is already present in the class thread, and this get.name is giving me the name of the thread which is already running in the background, which is main. Very simple. Now, JVM is something. JVM stands for Java Virtual Machine. So this is very important. JVM runs the main thread. We need not specify JVM, or we need not write any sort of code to run the main thread. But JVM itself invokes the main thread. That is why this thread, which you just saw, is being shown. Now, what if we want to create our own threads? What if I want to create my own thread? Is there a way to create a thread? Yes. In fact, we have two ways to create the threads. There are two ways we can create our threads. First way is by extending the class thread which is present in java.lang package, and the second way is by implementing the interface runnable. And in both cases we need to do one thing, which is to override the run method. In both cases we need to override the run method. I'll be explaining about these in a while. Okay, let's go back to Eclipse and let's create one class. Let me create a class with the name thread A. Let me call the name of this class as thread A, and I'll click on finish. I'll be illustrating about the first way of creating the thread, that is by extending the class thread. All right, to extend a particular class, we have a keyword called extends. All right, this is the keyword that we need to use for extending the particular class. All right, which is the class that we need to extend, which is thread present in java.lang package. Done. Now we have extended the class thread, but we need to override the run method as well, right? In both cases we need to override the run method. So in first case also we need to override the run method. Okay, the run method will be something like this: public void run. Okay, inside this run method I'll write one statement. I'll write it as inside thread A's run method. That's all. Okay, this has been created. Thread A has been created using the first way, that is by extending the class thread. Okay, now I'll go back to the main class to check whether it has been created or not. What I'll do is I will create the object of our thread class which we just created. How to create the object of a class? It is by using the new keyword, new operator. All right, thread A. That is the name of our thread which we just created. So thread A is equal to new thread A. Okay, we have created its object. Now there is one method present in run. Okay, there is one method present in this thread A class, which is that this is that is nothing but run method. Okay, do we need to call that method inside the main class? Do we need to call? Let's try to call it. It's okay, you'll not get any compile time error, and this is not the way to start a thread. All right, to start a thread you have a separate method called start. Here you go. This is the method that starts any thread. So you need not call the run method explicitly. JVM will take care of that. JVM is again Java Virtual Machine. That will take care of that. But you explicitly must call the start method of that thread class. All right. Okay, let's try running it and check whether our run method is getting executed or not. Yes, inside thread is run method, which is this. So internally, JVM is calling the run method, and we developers are not supposed to call the run method explicitly, though we don't get any compile time error, right? So thread A is now a thread because we have extended that extended thread class, and we have overridden run method as well. Okay, this is how we create the thread by extending the class thread. Okay, now let us understand the second way by implementing the interface runnable. For that, I'll create another class thread B. I'll call that as thread B. And again, to implement something, to implement any interface, we have a keyword that is implements. What are we trying to implement? We are trying to implement the runnable interface, correct? We are trying to implement the runnable interface, which is present in the java.lang package again. Now, this time, as soon as we tried implementing this runnable interface, we are getting one compile time error. So it is asking us that it is saying that the type thread B must implement the inherited abstract method runnable.run. It is explicitly asking me to override the run method right now. Okay, I'll click on that and I'll click on add unimplemented methods. In that case, a run method will appear here and it has been overridden. Now I don't find any compile time error, correct? Yes. Now let me write one statement inside this. I'll write inside thread B's run method. Okay. Now we have satisfied both the conditions. That is, we have implemented the runnable interface. Our class has implemented our runnable interface, and it has overridden the run method as well. Correct? By implementing the interface runnable, and we need to override the run method. We have followed both the conditions. We have satisfied both the conditions. Now let's check in the main method. First, let me create the object of thread B, which we just created. Thread B is equal to new thread B. Then here you need to create the name of the you need to create the object of the class thread also. Thread is equal to new thread, and inside that you need to pass this as the argument to the threads constructor. This thread B which we just created, I will be passing that reference variable into this. Okay, now using this reference variable thread, I will call this statement. That's all. Thread dot start. That's all. Now we need to check whether the run method of thread B will be getting executed or not. Let's run the program. Yes, inside thread B's run method is also getting executed, which means your class thread B is user defined thread, which is created by you. Okay, remember, you need not call the run method explicitly, you just need to call the start method. Okay, hey there, welcome back again. In the last class we studied about threads, multi-threading, and advantages of multi-threading, and also we understood how can we create the user defined threads, right? So in this session, what you'll do is you'll learn about states of the thread. Okay, you learn about the states of thread. A thread can be in any of the five states, which I'll be writing it now. The first state would be new state. The second state would be runnable state. And the third case, in the third state would be a running state. And the fourth state would be non-runnable state. And the fifth state would be a dead state. These are the five states of a thread. Given at any point of time, a thread can be in any of these following states. Let's understand about new state. When will our thread be in the new state? Okay, our thread will be in the new state as soon as we, create the object of the thread using the new operator. What do I mean by that? For example, let's say we have created thread A, right, in the last class. Let's create the object of it again. Thread A is equal to new thread A. Okay, as soon as we write this line in Eclipse, as soon as you write this line in Eclipse, the thread will be moved to the new state. The thread will be moved to the new state. Let's check that in Eclipse. Let's go back to Eclipse. Let's create the object of thread A. Thread A, thread A is equal to new thread A. All right. Now, how to check? How to check the state of this thread? Let's use the reference variable thread A, and let's call the method getState. We have a method called getState, and using that method, you'll be able to know in which state your current thread in. Okay, let's print it. Let's check in which state thread A is currently in. Okay, let's run this program, and there you can see the thread A is in new state. As soon as you write this line, as soon as you create the object of your thread will be in the new state. Okay, we understood about new state. Let's talk about runnable state. Okay, when will the thread be in the runnable state? When will the thread be in the runnable state? Once the start method is called, our thread will be moved to runnable state from new state. Once the start method is called, our thread will be moved to runnable state. Let's understand that. We already have that reference variable, right? Thread A dot start. I'm calling the start method of a thread, and in this case, as soon as I call this start method, the thread A should be moved to the runnable state. Let's check. Let's print the same line here. Uh, to get a better clarification, what I'll do is I'll write some comments like this. Okay, this will be in the new state, and as soon as you call it, okay, this will be in the runnable state. Okay, yeah, here I created the object of the thread using the new operator, and I'm printing the state of it. I'm trying to get the state of it. I'll be getting new because it is in the new state. The thread A is in the new state, and then I'm calling the start method, and now it should be in the runnable state. Let's run and check that out. Here you can see the thread after calling the start method has been moved to runnable state. Okay, and There are some other points that you need to remember about runnable state. If the thread is if the thread is moved to the runnable state, if the thread is moved to the runnable state, will that thread be considered alive? Let's check it out. Or when the thread is in the new state, will the thread be alive? Let's check it. Let's use the reference variable thread A, and then we will use a method called isAlive. I'm checking it to check whether to understand whether the thread is alive or not. Okay, after creating the new after creating the object of the thread, it was moved to the new state, right? So I'm checking whether the thread is alive in the new state or not. This time what I'll do is I'll print this. Okay, now I will comment this. Now I'll check. Now we know that the thread is in the new state, and we are checking if the thread is in the new state, will that thread be alive or not? Let's run the program and check. No, it is not alive, which means if a thread is in the new state, it is not considered to be alive yet. Okay, all right, you'll have a question. So when will a thread be alive, right? As soon as you start the thread, as soon as you start the thread, your thread will be considered alive. Now you can see the magic. Here you go. Once a thread has been moved to the runnable state, the thread is considered to be alive. That is true. Is alive is true. Okay. Now we understood about the runnable state. Now let's talk about running state. As soon as JVM starts the run method, or JVM invokes the run method, a thread will be moved to a running state from the runnable state. Okay, a thread will be moved to running state from the runnable state. Uh, if a thread is, if at all you want a thread to be moved to running state, it can be moved only from runnable state. A thread can be moved to running state from only runnable state, and from no other state you can move a thread to a running state. Any thread that you want to move to running state, it has to reach the runnable state, and only from runnable state a thread can be moved to a running state. This is very important point. Also, let's say this is a runnable state. Okay, let's call this as runnable state here, and after runnable state you have running state, right? There can be any number of threads here. Let's say that there can be any number of threads. Let's say there are 6 or 7, 8, 9, 10 threads right now. As soon as JVM calls the run method, like I said before, a thread will be moved to the running state. But there are 10 threads here. Which thread should be moved to running state? Or how many threads will be moved to running state? Given at any point of time, given at any point of time in the running state, there will be only one thread present. Okay? At any point of time in a running state, there should be or there will be only one thread that will be appearing in the running state. This is extremely important. So which thread will be moved to running state from runnable state? Because we, like I said, we have 10 threads here, and which thread was moved to running state? That is completely based on scheduling algorithm. JVM thread scheduler negotiates with the OS and decides which thread should be passed to running state. It's time now to talk about non-runnable state. If a thread is in the sleeping state, or in the waiting state, or in the block state, Such state of the thread would be considered as non-runnable state. Let's talk about sleeping state. Let's go back to Eclipse. Here we have already created the object of thread A, and we have already started the thread A. Right now it will be in the runnable state. And if we try running this, you will be able to see thread A is running at the background. Okay. Now let's call thread B. Let's call thread B after a few seconds. Like after a few seconds, let us call thread B. So what I'll do is I will create the object of thread B now. Thread B. Thread B is equal to new thread B, and then pass the object of this thread B into the threads constructor. Yes. Now the thread B is ready to be started. Like it is now in the new state. Now I'll use a for loop. Int I is equal to 5, I greater than 0, I minus minus. I'll use a for loop to make my thread A sleep for certain seconds. So what I will do is I'll call the sleep method of thread A. How do I call the sleep method? Since sleep is a static method, I will call it using the name of the class rather than using its reference object. So thread A dot sleep, and I will pass. Let me pass. 1 second as of now, or 1000 milli seconds now. And now I'm getting an exception because it is an handle exception type interrupted exception. Okay, I'll quick fix it, and I'll surround it with try and catch, and now the exception is gone. So now what happens is it once the execution starts, the for loop execution starts. I is equal to 5, I greater than 0, I minus minus. Yes, I is equal to 5 and I is greater than 0. So try block will be executed. It will make the thread A to sleep for a second. Okay, after 1 second it will go back. I mean the I value will be getting decremented. So in that case I will become 4. Is 4 greater than 0? Yes, it is again greater than 0. Again the try block will be executed. So it happens for 5 seconds until and unless I reaches 0, right? Until and unless I reaches 1, because I is greater than 0 is what I have given as the condition. So now once once I reaches 1, I want my thread B to be called. That is by I'll use the start method. I'll use the thread dot start to start the thread B. So after 5 seconds, of A's execution, thread A's execution, my thread B will be getting started. Let's run it and check. Yes, thread A is running. After 5 seconds, thread B should run. Yes, it is working fine, which means we have made thread A to move to the sleeping state. That is the non-runnable state. So that is the importance of this sleep method. Once that time is elapsed, it will be moved back to the runnable state. Once this execution is completed, it will be moved back to the runnable state and not directly to the running state. Okay, so non-runnable state. This is non-runnable state. So here we are using the sleep method. So once this time what we passed here is elapsed, it is moving back to the runnable state, and only after moving back to the runnable state it will be moved to running state based on the JVM's scheduler. Okay, so that is all about non-runnable state. And there is another method like wait and notify and all, and I will be teaching about all those methods in the future classes. As of now, you can understand that sleep method will let, I mean, will let the thread to move to the non-runnable state, and after certain time is elapsed, the milliseconds that we give, once that is elapsed, it will be moved back to the runnable state. Okay. Now you need to remember that once if the thread is moved to the non-runnable state, that doesn't mean that thread is not alive. Even though the thread is moved to the non-runnable state, it will be still alive. This is very important and you need to know it. Now, let's understand about dead state. We so far understood about new state, runnable state, running state, and non-runnable state. The only thing that is left is dead state. So, when will the thread be in the dead state? When a thread, when a thread completes its execution, when a run method of a thread completes its execution, a thread will be considered as dead. So once all the lines that you write inside the run method gets executed, the thread would be considered as dead. Remember this. And one more thing, apart from runnable state, running state, and non-runnable state, apart from these three states, in any other state, in any other states, the thread will be not alive. The thread will be alive only in these three states: runnable state, running state, and non-runnable state. And thread will be dead in new state and dead state. This is very important. And thank you. This is all about states of a thread. I hope you understood everything about this. And thanks for watching this video. And stay tuned for more such videos.